Everybody, today I'll be demonstrating a wave tank. In this demonstration we'll be doing the double slit interference pattern and refraction. But first, let's start with refraction. When water waves hit shallow land, the waves slow down, which causes damage to coastal areas. We can see this with our demo when the straight waves hits the underwater surface. For this demonstration, we can use the depth to wavelength ratio to see the speed change between the two wavelengths. Our initial depth is 1 cm with a wavelength of 0.9 cm. Our second depth is 0.3 cm with 0.5 cm wavelength. We can use our ratio to see that there is a change in speed associated with the change in depth. Refraction is the change in direction of a wave as the depth changes. Refraction occurs when the wave hits a barrier at an angle. The angle of refraction can be calculated using Snell's law, and it will cause the wave to change direction. The second demonstration I want to talk about is the double slit interference pattern. The double slit experiment can be shown by using 2 point sources attached to the wave generator and using a high volt pattern. Interference occurs when the two waves with the same frequency and constant phase difference make contact with each other. We can see that there are areas of waves and areas without. These are called fully constructive and fully destructive interference. During fully constructive interference, the two waves from the point source collide, resulting in a single wave with double the amplitude, causing a maximum. During fully destructive interference, the crest of one wave and the trough of the other overlap, resulting in the amplitude of the single wave to be less than the individual wave. If the peaks that are perpendicular to the point source are maximum, then the waves are in phase. Likewise, it's a minimum, then it's out of phase. In this video, I will show that the path-length difference equals the order number times the wavelength. Through algebra, the path-length difference equals d sine theta. The difference between the length of the line between each point to the central maxima of the fully constructive peaks. For the 0th order maxima, the path lengths are both 11.5 centimeters and the wavelength is 0.8 centimeters. We can see from the formula that it does in fact equal the order times wavelength. For the second order number, we can measure R1 to be 9.0 centimeters and R2 to be 8.2 centimeters. The difference between them equals the wavelength. This can be repeated for each order number. The difference with fully destructive interference would be to calculate the difference with association to the order number plus half, then times the wavelength. Interference can only occur when waves from the source emit constant phase with respect to one another, as well as they have to have identical wavelength. Other fun physics demonstrations that can be done with a wave tank include reflection, diffraction, and Doppler effect. Thanks for watching!